Oh no. I have a geometry test on right triangles today and I forgot to study. What am I gonna do? Where are my notes?
Don't panic.
Who said that?
You need to learn geometry really fast, don't you?
Yeah, I do. Mystery voice.
Well, sit back and listen, because I'm going to help you. You need to learn geometry, more specifically right triangles. Let's start at the basics. First, you should know that there are 3 types of angle named triangles: acute, obtuse, and a right triangle. Don't worry about those 2 for now. Let's focus on right triangles. A right triangle is made up of 1 90-degree angles, and that's marked with a box. The definition of perpendicular lines are lines that form right angles. So, if your triangle is made up of perpendicular lines, then you know you have a right triangle. There are 3 sides that make up a right triangle. 2 of those sides are legs. The legs make up the right angle. The other side of the triangle is called the hypotenuse. It's the longest side of the triangle, and it's the opposite side of where the right angle is located. Now you know what a right triangle is made up of, so how do you know if 2 right triangles are congruent? There are 4 postulates on how to prove that 2 right triangles are congruent. The first way is leg-leg congruence, LL. If both legs of both the triangles are congruent with each other, then both of the right triangles are congruent. The next postulate is hypotenuse angle congruence, HA. If the hypotenuse of both right triangles are congruent with each other and any angle of the triangle except the right angle is congruent, then the 2 right triangles are congruent. Remember not to include the right angle of the triangle as an angle for the postulate. The third postulate is leg-angle congruence, LA. If one of the 2 legs of both the right triangles are congruent, and one of the angles that is not the right angle of both the triangles are congruent, then the 2 right triangles are congruent. Remember, don't include the right triangle as an angle for this postulate. Our next postulate is hypotenuse leg congruence, HL. If the hypotenuse of both triangles are congruent and one of the legs of both triangles are congruent to each other, then you have 2 congruent right triangles. Remember, you can only use these postulates if both the triangles are right. So you have to prove that the triangles are right to use these postulates. Let's see if 2 right triangles are congruent.
How did we get out here?
For now, that doesn't matter. We're going to cut the window in half to make 2 right triangles. We know they're right because line AC is perpendicular to AB, and line CD is perpendicular to CD. Triangle CBA is right, and triangle CBD is right as well because of perpendicular lines. If we were writing this in the proof, first we would state that angle A is right and angle D is right, and the reason for that is definition of perpendicular lines. Then we would write triangle ACB is right and triangle CDB is right, and the reason for that is definition of right triangles. We don't have to do any measuring to see that segment BC is congruent to segment BC. If we were doing a proof, you would put in the reasons column that the reason is reflexive.
29 inches. 29 inches.
Segment AB is 29 inches and so is segment CD. So, segment AB is congruent to segment CD. Now we know that the same legs of both the triangles are congruent. Since we know that both the hypotenuses of both the triangles are congruent to each other and both the legs of both the triangles are congruent to each other, we can use the postulate we were talking about before, hypotenuse-leg congruence. Since we already know that the triangles are both right, we are allowed to use this postulate. So, our congruence statement says triangle ABC is congruent to triangle BDC by HL, hypotenuse-leg congruence.
I'm so gonna ace that test now. Thank you, Mystery Voice!